right, so this is DSMA 5. We're going to add, subtract, and multiply polynomials. We've got to have our exponent rules down. It's very important when we start multiplying polynomials that we're able to do those exponent rules quickly. So this is what we call function notation. This is called p of x. It's really just a name. So the capital P is the name of the function. Functions are like machines. We have inputs and outputs. And so the variable that is the input variable goes inside the parentheses there. And all that tells you is the variable that's on this right side. Okay, so P of x just means that x is the input variable, and that's what we're going to put into the function, and then we'll see what comes back out. So we are going to look for P of 7. What that means is every place that we see an x, we're going to substitute with a 7. Now, I always use parentheses because if it's a fraction or if it's a negative number, we have to have the parentheses, especially if we're going to put these into our calculator, which you can put the x's into your calculator except when we're graphing. But in the main window of the calculator, you can put the any numbers, right? As long as we don't have the variables, but just the numbers. So if you wanted to, you could put this whole side into your calculator. All right, so let's go ahead and clean this up. We have 49, 7 times 7, plus 7, plus 5. So that's going to give us, let's see, 56 plus 5. And so that is 61, right? And so what happens with these actually, when we have functions like this is actually an ordered pair. We put 7 in, right? We put x into the function, and we got 61 back out, and that is our y. So this is actually an ordered pair for this function if we were trying to graph. Here we have a word problem. It's actually a physics word problem. It says an object is dropped from the top of a tower with a height of 1,110 feet. Neglecting air resistance, the height of the object at time t seconds is given by the polynomial negative 16t squared plus 1,110. In case you're interested, this is tied to gravity inside the formula for the physics for dropping, and it's, of course, gravity on Earth. And then the 1,110 has to do with the height at time 0. So this is t seconds. And we want to find the height of the object if t is equal to 4. So we're going to put 4 inside our function. And so 4 is going to go inside here. Let's grab our calculator. Okay, so inside our calculator, we're going to make it look just like what we had up here. And it looks like we get that after 4 seconds, the height of the object is 854 feet. Okay, so just plug and chug. A lot of the problems in college algebra really are that way. It's just figuring out what they want. But the majority of them, we truly are just plugging in a number into a function. So it's just deciphering the word problem. All right, let's talk about like terms. We saw when we were working earlier that sometimes we would have terms like this, maybe like this, and we talked about that we could put the like terms together, so the x's could go together. 5x minus 3x gave us 2x, and that would be like having 5 cookies and giving 3 cookies away. You've got 2 cookies left. And then, of course, we can add the numbers together, so that would give us plus 3. But that's as far as we could go right there, because the 2 is times x, but the 3 is all by itself, so we can't combine those. Now, this also works with variables. Let's say I have a 7x squared plus 2x to the third power plus x squared. All right, so because this is addition and subtraction, now this was different when we were multiplying and dividing, then we could use exponent rules, but this is addition and subtraction. So my only like terms are the 7x squared and, of course, the 1x squared. Remember, there's an implied 1 sitting in front of any variable that looks like it doesn't have anything in front of it. So if we want to add these terms together, they have to look exactly alike. The variable has to be the same, and the exponent has to be the same. Otherwise, we can't add those together. So we can add the 7x squared plus the 1x squared. That would give us 8x squared. There's nothing we can do with this 2x to the third power. We cannot add those two together. We could multiply them, we could divide them, but we cannot add or subtract them because they look different. So this is what we mean by like terms. So let's try a couple problems here. All right, we have a lot going on here. We have what we call a polynomial. In the front here, we've got 4 different terms, and then we're adding, and we have 4 more terms. So this is adding and subtracting. This is not multiplying. And therefore, we have to put the like terms together. So I like to line these up. So I'm going to take that first polynomial, and I'm going to write my terms. And then underneath, I'm going to line up the like terms from the second polynomial, from this one. So the 7x to the third power would go with the negative 2x to the third power. They happen to be in order in this problem. They're not always. The 7x squared would go under the 3x squared, and so on. So now I have all of my like terms put together vertically, and I can just take care of the numbers that way. So I have a negative 2x to the third power plus 7x to the third power. So 7 minus 2 would give me 5, and the x to the third would come down. Because I'm adding, the exponents are not going to change. So this is what gets tricky. When we're multiplying or dividing, the exponents are going to change. When we're adding and subtracting, they're not going to. All right, then I have 3 plus 7, so that gives me 10x squared. Here I have negative 17x, and finally minus 4. All right, so all of that is my answer. I'm going to have to put that whole thing into the box. So it actually takes longer to type it into the computer than it does to find the answer. If you like to do it horizontally, that's no problem. Just be careful that you are getting like terms together. Some people like to just grab the terms they need and cross them off. If you have a different method, you go for it. All right, so once again, I have all kinds of terms sitting here. I'm going to get started with the first 3 and write those. So with the first 3, I have 6a squared negative 8ab. Now notice these are all different, right? None of those are alike because one has a squared, one has a times b, one has b squared. I can't add any of those together. They are not like terms. But notice my next term is negative 4a squared. Well, I already have an a squared, so I can put that right here, and that way I have like terms vertically. Then I have negative 6ab, or minus 6ab, put that right there. And finally, I have plus 9b squared. So once again, I have all of my like terms lined up together so that I can easily look at them. So here I have 6 minus 4, so that gives me 2, and the a squared stays put because I'm adding and subtracting. Negative 8 plus negative 6 gives me negative 14. Again, the AB stays as it is. And then finally, 5 plus 9 is 14. And I'm left with the B squared. So all of that is my answer because those are not like terms. There's nothing else I can do with those. All right, with subtraction, we do have to be a little more careful. We do have to go ahead and distribute. Remember, this is a -1 out in front of the parentheses, and so I do need to distribute that subtraction sign before I start trying to add these together. So that would be -1 times -6 would give me a plus 6y, and then -1 times +2 would give me -2. The biggest mistakes on tests are forgetting to distribute all the way along. It's very obvious to distribute to the first term, but you have to distribute to everything inside the parentheses. All right, so now we can line these up. So we're going to take the first three. They are not like terms, so there's nothing we can do with those. I have a 6y, I can put that here. And I have a -2, I can put that there. All right, the y squared doesn't have a second term. That's okay. We're just going to go ahead and bring it down, just like adding 0 to 4y squared. Then I have 15y minus 11. And that's my answer that's going to go in. So very careful with subtraction. We have to make sure that we change all the signs in the parentheses after the subtraction sign. And then we can start combining like terms. Okay, we have a lot going on here, but these are all polynomials. All of them we're adding together. There's no multiplication in sight. However, we do need to go ahead and distribute this subtraction sign. So that's a -1. We're going to multiply that inside. When we do that, we get a -8x squared and then plus 16. Be careful. So -1 times 8x squared gives us -8x squared. -1 times -16 gives us a positive 16. Now we can still line these all up, right? We have 3x squared plus 8x minus 2. Then we have a plus sign, so we didn't have to distribute. We have 5x squared, so that would go here. We have a 9x, that would go here in this second column, and then plus 19. And then finally, we have a -8x squared here and a plus 16 over here. So now we can add all of these up. Okay, so if we add up that first, oh, look at that. We have 3 plus 5 is 8. So we have 8x squared minus 8x squared. So that ends up being 0. We're not going to put 0x squared. We're actually not even going to put 0, but let me put it for right now. Then I have 17x, and then -2 plus 19 plus 16, I think it's 33. So we're not going to worry about the 0 in front. If you want, you can write 0x squared, but I don't think the computer is going to take that. So I have 17x plus 33 is going to be my final answer. All right, so now we're going to start multiplying. So this is different than what we did in the exponent rules, because notice that we have addition inside. Okay, with the exponent rules, we did not have addition. We had like 2x times 8x, which is a whole different problem, because then we could just multiply 2 times 8, which gives us 16, x times x, which gives us x squared. But it doesn't work that way for these. Because of the plus sign, we have to actually distribute. And so what we do is what we call FOIL. If you go on to pre-calculus, don't tell them that we FOIL, but we do. Okay, so this is first, outer, inner, and last. Okay, so what we're going to do is we're going to do first, outer, inner, last. First, we're going to take the two first terms, so that's x times x plus, Then we're going to take the two outer terms, and so that would be x times 8. Let's grab with green. Now we're going to do the inner terms. So that would be 2 times x, and then finally the last, and that would be 2 times 8. Okay, so we have x times x. That would give us x squared. I'll go back and look at that in just a minute. Then we have x times 8, but we like to write it this way, 8 times x. Then we have 2 times x, and then we have 28. Now I'm not done there, but let me go back. I just want to go back and look at this problem again. So we take the first terms, and for us in this problem, that would be x and x. So we took x times x here. Then we took the outer terms. So for this problem, that was the x in the front and the 8 at the end. That was here. Then we went to the inner terms. So that was 2 times x from the inner terms. And finally, we take the last two terms, which is 2 times 8. This is just a systematic way of doing it, and you can start doing it pretty fast, just kind of eyeballing it. And then that's going to really help when we start factoring and we have to go backwards. Okay, but we're not done here. If you put x squared plus 8x plus 2x plus 28 into the computer, it's going to tell you that although you have the correct answer, it is not in the correct format. And that's because these middle terms are like terms. That happens a lot of the time, not always, but a lot of the time. So we would end up with x squared here. 8x plus 2x would give us 10x. And then finally the 28. So now it is simplified. We cannot combine any of those because we have an x squared, an x, and a 28. And so that is our answer. We have now multiplied those two. We actually call those binomials because there's two terms. All right, let's try another one. All right, so once again, we have two binomials. We have addition and subtraction inside, so we can't just multiply these using exponent rules. We will use exponent rules, but first we have to grab what we need. For the very first term, we're going to grab the first two terms from the binomials and multiply those together. So that would be x times x. Then we would have a plus sign. Then we're going to take the outer terms. So the outer terms means that I'm going to take the x here and the -2 here. So x times -2. I cannot get the stylus to work. Then we're going to do our inner terms. So that would be 5 times x. And then finally, we want our last terms. And that would be 5 times -2. Okay, so we took the first terms, we took x times x, then we took the outer terms, so we took x times the -2. Then we took our inner terms, so that was 5 times x. And then finally, we took our last terms, and that was 5 times the -2. Okay, so once we did that, we get x squared plus -2x plus 5x minus 10. And we have like terms in the middle again that we can add together. So we get x squared plus 3x minus 10. And that is our final answer. That's all cleaned up. It's multiplied. Now, if you've learned a different way to multiply these binomials, you go right ahead. But if you don't have a set way that you like to do it, this is great. It just kind of keeps it more organized this way.